product rule.
Okay, good day, class. Today we'll be looking at under differentiation, calculus differentiation. We'll be looking at the differentiation of a product. That is the product rule. The product rule. Now, the product rule states that the derivative of a product of two functions is equal to the second function multiplied by the derivative of the first function plus the first function multiplied by the derivative of the second function. It's very simple. So the product rule states that the derivative of the product of two functions. So if you have two functions, let's say the function is u times v, their product. What happens is that it says that it is equal to the second function, which is the v, multiplied by the derivative of the first function u, plus the first function u, multiplied by the derivative of the second function what? V. So now what happens is that the u and the v, they should be functions of x. So if you now have u, y is equal to u times v, where u and v they are functions of x, then the law says that the v should multiply, because if u is a function of x, so u is a function of x, and the v is also what? A function of x. So if u is a function of x, v is a function of x, then the derivative of their product, the dy dx, should simply becomes what? The v, the first function, times the derivative of this function. So if you want to find the derivative of this function, it's the u on the x. The derivative of this function becomes the v on the x. I get it. The v on the x. So therefore, the derivative of the product, the two functions multiplying itself, becomes v times the du on the x plus u times the derivative of the second function, the v on the x. And this is what we term as what? The product rule. Let's take some two examples on this. The first example says y is equal to x minus 3 multiplying x squared plus 7x minus 1. Multiplying x squared plus 7x minus 1. Okay, so this is the function. Now realize that these are two functions together. X minus 3 is multiplying another function, x squared plus 7x minus 1. So this is two functions together. How do you find the derivative of them? Now what happens is that we have to represent one function. So let's say, let u be equal to x minus 3. And let v be equal to x squared plus 7x minus 1. Okay, so now we've been able to. So that means if you use this and this, y now becomes u times v. So what do we need? We need this u on the x, because u is not a function of x. So u on the x, what will it be? We differentiate each term from the general rules of differentiation. So differentiating x as a constant to give you 1, because here's 1 times 1, and this 1 minus 1, so it's the same as what? 1. I get it. And differentiating a constant is 0. So minus 3 here, if you differentiate it, it's 0. So it becomes 1 minus 0, which is the same as what? As 1. Okay, and you have to find also to what? The v on what? The x. When you find the v on the x, you get 2 times x, 2 minus 1, which is what? 2x plus 1 times 7, that gives what? 7. Because this one goes to 1 minus 1, which is x is equal to 0, which is 1 times the 7. And this one gives you differentiating a constant is 0, so you can decide not to bring it. So this is what you get. Now, this is the formula. The formula says that if you want to find the derivative of a product, it is what? The v times the u on the x plus u times the v on the x. So therefore, the y dx is then equal to, what is v? V is the function here, which is what? X squared plus 7x minus 1 times the u on the x. What is the u on the x? Times 1. So the u on the x here is 1. Plus, what is u? U is what? X minus 3 times the v on the x. This is the v on the x, which is what? 2x plus 7. I get it. So when you get this, you now simplify it. You get x squared plus 7x minus 1. So it multiplies minus 1 will do the same thing. Plus, this and this will give you 2x squared plus 7x minus 6x minus 21. So now dy dx therefore become 3x squared, that's x squared plus 2x squared plus 8x. So this one give you only 1x here, 7x minus only 1x plus this will give you 8x. And now give you minus 1 minus 20, this is about minus 22. Okay, so this becomes the final answer, the derivative. Let's take one last example under the product rule. One last example under the product rule. Okay, so y is equal to 4x cubed minus 2 multiplying 5x squared plus 3x exponent 4. Okay, so as usual, you take your u is equal to 4x cubed minus 2 and your v is equal to 5x squared plus 3x exponent 4. Okay, so if that's the case, you find the u on the x. And the u on the x will give you 12x squared differentiating the constant is 0. And the gain on the x is equal to 10x plus 12x exponent 3. 12x exponent 3. Okay, so now finding that, you state your formula, and this is already your formula. Okay, so therefore, the dy of the x is equal to the v, which is 5x squared plus 3x exponent 4, multiplying the u on the x, which is 12x squared, plus the u, which is 4x cubed minus 2, multiplying the v, which is 10x plus 12x exponent 3. Okay, so when you do this, then your dy dx now becomes, you have to now simplify everything. So you get 60x exponent 4 plus 36x exponent 6 plus 40x exponent 4 plus 48x exponent 6 minus 20x minus 24x cubed. So therefore the dy of the x grouped like things become 84x exponent 6 plus 100x exponent 4 minus 24x exponent cubed minus 20x. And this becomes the final derivative. Let's meet in other videos for quotient.